Question 16, the graph shows the distance travelled by a particle over the first 20 seconds of its motion. Show that the average speed of the particle over the first 20 seconds of its motion is 1.8 meters per second. So this is actually just a speed question. It goes, so we want speed as distance over time. So we're going to go, the distance travelled is 36. It's difficult to see on here, but there's 35. It's one above, so 36 divided by 20 seconds. 36 divided by 20. I can halve them both. 18 divided by 10, 1.8. There we go. So I've proved it, 1.8 meters per second. Okay. Estimate the speed of the particle at 10 seconds. I need a tangent. Okay, this is a question where I need a tangent. It's a curve, so I need a tangent to the curve at 10 seconds and show working to support your estimate. But the first thing I need is a tangent at this point. If I just move it around a little so I can get my pen. Whereas 10 seconds is there. You can see I have traced out my line a little bit to help me when I do it so I don't make a mess of it. And there we go. So here's my point. You can see it's just crossing here, and I'm going to pick 2 points. So I want the gradient. So this is the estimated speed. I want the gradient of this line. So the gradient of my line is rise over run, change in y over change in x, or whatever you want to call it. So I'm going to use this triangle here. Okay. So it's there and there. So I can see this is 5 seconds across the bottom, and if I look here, this is 6 on the side, so it's going up. There's 30 to 35 is 5, and one more is 6. So we've got change in y is 6, change in x is 5. 6 divided by 5 is going to give me a 1.2. So it is 1.2 meters per second is the estimate for the speed at 10 seconds. You would have got anything, you would have got marks for anything in the range of 1 to 1.5 because we're not all going to draw exactly the same tangent. Okay. Then, so we've got the diagram on this side, then we've got a diagram with a triangle and an angle marked. So my first instinct is trigonometry, but I do notice that there's no angle, right angle been marked. So question marks, I've got 2 sides and an angle sandwiched in between. So 7 meters and 8 meters, and it says find the area of the triangle. I'm not going to assume anything. It does not say there is a right angle in this triangle, so do not assume there is. Give your answer in the form A, root B, where A and B are integers. Okay. So what you actually need to do here is I don't have a right angle, so that's leaving me with non-right angle trigonometry. And because I'm talking about area, I'm going to use trigonometry for the area of the triangle. So it's a half AB sine C. Okay. So these are A and B, that would be C over here, and this is the angle C. So that should really be a capital C, but it's difficult to show on here. So a half multiplied by 8 and 7 multiplied by sine 45 is what I'm looking for. So that's area equals, the area is a half times 8 is 4, 4 times 7 is 28. So I've got 28 times sine 45. So I can either have memorized all of my exact trig values or can think back to working it out. So there's 2 triangles to remember for your non-calculator. The first one is this triangle. It's an equilateral triangle where all the sides have got a 2, which means that this is a 60-degree angle, this is a 60-degree angle, and if I split it in 2 with a right angle there, that gives me my 30-degree angle. So that's the one I can use to work out sine 30, sine 60, cos 30, cos 60, tan 30, tan 60. However, 45 degrees, I draw a right angle triangle. Okay, and it's an isosceles right angle triangle, so these are both 45. I'll just mark one for now. This is 1 and 1. Okay, so I'm going to use trigonometry to work out what this side is. So it would be 1 squared plus 1 squared, which is 2, and square root my answer, square root of 2. So 45-degree angle down here, 1, 1 and 2. So if I want sine 45, opposite is 1 over the hypotenuse root 2. So 1 over root 2. So that's what I'm going to change this to now. So 28 times 1 over root 2, which leaves me with 28 over root 2. So it's asking me, though, to give it in the form of a root b. So I'm going to need to rationalise my denominator, another rationalised denominator. So I'm going to go 28 over root 2, and I'm going to multiply it by 1, but in the form root 2 over root 2. So it cancels out my root 2 at the bottom. So 28 times root 2 is 28 root 2. Root 2 times root 2 is 2. So I can do 28 divided by 2 is 14 root 2, and that's in the correct form. So 14 root 2. Okay, that's that one done. So just to finish off that one as well, if you were working out this, so this is the 1 and 1, and you'd want the inside one, so you'd do 2 squared, take away 1 squared, because this is the hypotenuse, so 2 squared is 4, take away 1 squared is 3, so the inner line would be root 3, and you just use this side to work out all your trig values. Okay. All right, then we've got factorising now. Factorising, find the root. So this is just asking me to solve it, so factorise it and use that to solve it. So first thing I'm going to do is say x squared plus 18x plus 77 is equal to 0. Right, so factors of 77. The obvious one is 11 times 7, and quite handily, 18 is 11 plus 7, so that's a nice easy one. So x, and everything's positive, so there's nothing difficult about this one. X plus 7, x plus 11 equals 0. So we're multiplying to make this one, we're adding to make this one. So 7 times 11, 7 plus 11. And those two numbers go here. So solving it then. So if I'm solving it, what I'm saying is this has got to equal 0, which tells me when I multiply two things together to get an answer of 0, one of them has got to be 0. So if this bracket was equal to say 0, x plus 7 is 0, then this must have been minus 7. Minus 7 plus 7 is 0. If this one equals 0, something plus 11 is 0. It must have been minus 11. So x is either minus 7 and it's minus 11. Right, it then asks me to put it in this form, and this form is completing the square. So x plus a squared minus b. So it wants me to put it in the completed the square form. So to do that, take the first section, so the x squared plus 18x, and I'm going to half this number here and put it into brackets. Get rid of any squares here, so it's x. Half of 18 is 9 squared. Okay, that's the first step. And I'm going to then take away 9 squared, and I've still got plus 77. Okay, simplify this bit. Here we've got x plus 9 squared minus 81 plus 77. So my final answer should be x plus 9 all squared, and then we're going to have minus 4. Difference between those is 4, so minus 81 plus 77 would leave with minus 4. Why do we do all this? Because if I were to take this bracket and multiply it out, x plus 9 squared, so x plus 9, x plus 9 multiplied together. So you're going to get x times x is x squared, x times 9 is 9x, 9 times x is 9x, added together that's 18x. And then finally, you would do 9 times 9, which is 81. Okay, which means that we've got this now extra added in, which is why we then do this step. Okay, so that's what is happening there, and that's why we then take it off again. Write the coordinates of the turning point of the graph. Okay, y coordinates dead easy. Just take the minus 4, and that's it. the x coordinate is the same as up here as when we solved it. How do I make this equal 0? Well, if x plus 9, it's got to be minus 9 to make that equal 0. Minus 9 plus 9 is 0. Okay. Sketch the graph of 5 to the power of, that's a really small x, 5 to the power of x, indicate any values where the graph crosses the axes. These are where we've got a power, the power is the x value. So there's two things we know here. We know it's never going to have a negative value. It's going to, as the values get smaller along the minus numbers here, we're going to get closer and closer to 0, but we're not actually going to meet it. The other thing I know is that anything to the power of 0 is 1. So it's going to cross here at 1. And I'm going to do a terrible job of drawing a sketch where it curves up like so. Yours would be obviously much nicer. Should be nice curve straight up here. All right then, we've got sketch the value of y equals tan x for the values between 0 and 360 degrees. Indicate where it crosses the x-axis. Right, I'm going to split it up first of all. 180 in the middle, 90 would be in the middle of that, and 270 would be in the middle of it. It's not perfectly spaced, but they're there. So we know there is no value for tan 90 if you put it in your calculator. There's also no value for tan 270. What we do have is these beautiful little curves. So the first one here is a bit like this one. It's going to get really close to this line here, but it's never going to reach it. And then it's going to get to 0 and it's going to stop at 0 there. It's going to meet at 0. Okay. This one at the end, it's going to come this side. So it's going to start at this line, is really close, but never actually going to touch it. And then it's going to curve up and reach the graph at 360, hitting 0 there. What's going to happen in this middle section is it's these two bits put together really. So it's going to start over here at this line, really close, curve down and cross into 180, curve in the other direction and then get close to this line but never actually touch it. And that is the graph of tan x. To get your marks this here, so not only do the sketches of these lines have to be correct, but you've got to mark 180 on the graph as the crossing point. Okay. Right, moving on then. Question 20. We've got a box. So your first instinct is probably going to be cuboid, going to be doing volume. It's not, sadly. Chi is a box in the shape of a cuboid. The internal dimensions of the box are 10 by 4 by 6. Kai is given a pencil, its length is 13 centimetres. Show the pencil does not fit completely inside the box. Right, well we know it's not going to fit this way, it's not going to fit this way, it's not going to fit that way. What it's looking for is it going to fit at the widest point, which is going to be a line that joins this front corner to this very back corner here. So this is actually a 3D Pythagoras question. So we're going to have to come up with a question. Well, we've got a little triangle that reaches the back here. So what we've got is a triangle that is 6 centimetres high, but I don't actually know anything else. And this is the dimension that I want to find. Okay, it's going to be right angled. Oops, that's a round one. So we're going to need to start with looking at this base. We want to know what this baseline running across this diagonal here from the front corner to the back corner is. So starting with that, that's a 10 by 4 rectangle. And I'm going to split it in two because I want that line there. Okay, so using Pythagoras, I've got 10 squared plus 4 squared is equal to c squared. Okay, 10 squared is 100, 4 squared is 16, and that's 116. So this line is the square root of 116. I'm not going to square root it yet though, because I'm only going to square it again when I put it in here. Which line is it? Well, if we look at this triangle, it's the bottom line here. It's not the hypotenuse. So it's the square root of 116. Okay. So now I know this looks like I've worked out backwards, but I just find it easier to start from what do I need and how am I going to get there. So we're going to need to know what this line here is. So I'm going to call it x just because we call everything x. And so x squared is equal to 6 squared plus the square root of 116. squared. So you can see why I didn't bother to try and figure out what that would be. So I'm only going to square it again. So x squared equals 36 plus 116. X squared is equal to, all those going to sneeze there, 152. Right. So coming down underneath, show that the pencil does not fit in. So what we're trying to say is 13 squared going to fit here? So the length of the line is 152. So we know that the length across there is 152, but 13 squared is 169. So no, the pencil won't fit. There we go. And that is all the working I need. Now, ideally you'd have done the square of the rectangle up above, but I just like to work backwards. Okay. Question 21, another graph. Okay, we've got y equals 1 over x minus 2 between x values of minus 2 and 6. There are no values for which 1 over x minus 2 equals k. What's the value of k? This is coming down to we can't divide by 0. So what value of x is going to make it so I can't divide by 0? It's going to be 2. 2 minus 2 is equal to 0. Okay? Okay. Use the graph to find an approximate solution to the equation 1 over x minus 2 is equal to 3x minus 1. Give your answer to one decimal place and show your work on the graph. It's actually asking me to draw a line. So I'm going to need some values first of all. And we know that 3x minus 1, so the graph of 3x minus 1 is a straight line. There's no powers of x involved, so it's going to give me a straight line. So I can do this off just 2 values really, but I'm going to do 3 just to be safe. I'm going to start with x is 0 and y. So if x is 0, 3 times 0 is 0, minus 1 would be minus 1. If x is 1, 3 times 1 is 3, minus 1 is 2. And let's go for once a bit further along the line. 3 times 3 is 9, minus 1 is 8. So I'm going to plot all those points first of all. So 0, minus 1, so I'm going to have to move it off. Get it to move. So 0, it's going to be at minus 1. At 1, it's going to be at 2. And at 3, it's going to be here, 8. And this would be my final check. The reason I've done 3 and not 2 is because I can see that these make a straight line. So what I'm looking for is these 2 points here where they cross, which on my graph is, that's 1, 2, 3, 4, 5. So 5 points between 0 and 1, so each one's 0.2. So that is 0.2 by the looks of it. And going over here, again, we've got 2.2. And if I look at the mark scheme, it says that anything between 0.1 and 0.3, and anything between 2.1 and 2.3. So I'm slap bang in the middle, 0.2 and 2.2. Okay, show algebraically that 1 over x minus 2 is equal to 3x minus 1 has the same solution as 3x squared minus 7x plus 1 equals 0. What this is actually asking me to do is it's asking me to rearrange this and simplify it all down to see I get this equation here. So start off by writing it a bit bigger so it's easier to see. Equals 3x minus 1. Okay, so I'm going to start by multiplying by all of this just to get rid of it. So 1 is equal to 3x minus 1 multiplied by x minus 2. Get rid of my brackets. 3x times x, 3x squared. And normally I do this really quickly, but because I've got a number, a coefficient of x here, I'm going to write each one out. 3x minus 2 is minus 6x. Minus 1 times x is minus x, and minus 1 times minus 2 gives me positive 2. Negative times a negative gives me a positive. 1 times 2 is 2. So 1 is equal to 3x squared minus 6x minus another x is minus 7x plus 2. So we're most of the way there now. We've got 3x squared, we've got minus 7x, and the last bit is 1 and equal to 0. So that's this problem here. So if this at the moment is positive 1, take 1 from each side, of 0, equals to 3x squared minus 7x, and 2 take away 1 is 1. And that's shown it there. So 3x squared minus 7x plus 1 is equal to 0. 3x squared minus 7 plus 1 is equal to 0. Your marks aren't going to be for that line there. They're going to be for getting to that line realistically. So getting to this point, because it's already told me that that's what my answer is. And that would be the end of the test. Hope that helped. Thanks, guys.